we're going to talk about what chirality is. If you have a chiral substance, chiral is C-H-I-R-A-L-I-T-Y. And the definition for chirality is it cannot be superimposed It's that easy. Now, in order to be chiral, you need to find a chiral center. So that is the center that you're rotating on. And after you find your chiral center, the next thing you need to do is you need to find all your planes of symmetry. So usually there's a possible horizontal plane of symmetry. That's your X, Y, and Z. So what I have here is I have a dashed line. This dashed line is my mirror, because that is the easiest way to find out if you have a chiral particle or not. So what I'm going to ask you to do is we're going to just do a simple tetrahedron, which means we're just going to make a carbon, and the carbon is going to have 3 or 4 different elements attached to it. And I'm going to show you how it is chiral. Okay? So you're going to build it, and then we're going to draw it. So go ahead and build your tetrahedron. And you're going to need black color, you're going to need red, and 2 other colors. And it would be good if they were opposites. So like red, green, something very different from each other. So I'm not going to give this particle a name, because what we're doing is we're thinking about how it reflects in the mirror. So the reason why we have these things colored is so we can keep track of them and where they are in space. Okay? So notice I have to find my chiral center. For this particle, it's very easy. My chiral center is the C. So I'm going to put a C there. And I have to identify my plane. So I want this right here to be on my plane. So you can see that the yellow one is coming out of the page. Or you can see, I'm sorry, I misspoke. You can see that the blue and the yellow are on the page. So that's what I'm going to draw. But you can see that the red is going behind the page and the purple is coming out. So let's go ahead and draw that using our notation. So I'm going to have my blue up. And I'm going to have my yellow over here. And they're on the plane. How are you feeling about that? Good? Okay, now notice this purple one's coming out at me. So what am I going to do for that? I'm going to do my dart, color in my dart, and put my purple there. These bonds are all the same length, by the way. Now, what's going back into the paper? Into the lab bench or the surface is the spread one. So we're going to draw that going back. Remember, this is supposed to be a triangle. I'm not doing a very good job. And there's my red. So that's what this looks like. Okay? Now, here's what I'm trying to teach you. Oh, yeah. Yeah, no problem. How'd it go?
Good.
Thank you.
I just had Dawn dish soap, so I was as clean as I could get them.
Okay, perfect.
Do you autoclave?
No.
No.
Well, I do sometimes.
Okay.
Okay.
Thank you so much.
So, now, what is this is a mirror. What is the mirror image of this? How would I do that? These two are going to stay on the plane. So if I put this in a mirror, what would you see? What would be back and what would be forward? It would be this, right? This would be the mirror image of that. This would be on the plane. This would be a flat on the plane, right? Oops, sorry. This would be flat on the plane. Okay, let's keep track of this. This is flat on the plane. What would the mirror image of that be? I would roll it, right? Like that. Or would it be this? Or would it be this? What do you think? If you're confused, let's draw it. We're going to draw the things that are on the plane first around our chiral center. So here's my yellow, and here's my blue. Those are on the plane of the paper. Now, if I have a mirror image of this, where is this going to go? It's going to go back here, right? Oops. So that's going to be your red. And this right here is going to be down here. And that's going to be my purple. So do you see how they're mirror images of each other? Now if I take this right here, and I put it on top of that, do you see how it's not the same? Do you see how the red's here and it's not back here? That's what chiral means. Do you see my point? So if I take this and I put it on top of the image in a mirror, you cannot superimpose them. Your hands are chiral. Look at my hands. Mirror image of my hand is my other hand. If I take and put this hand exactly on top of this hand, like if I take it and go like this, and I superimpose it, they're not the same. My hands are chiral. So hands, they match. So if you have a mirror image and it matches perfectly, that means it's chiral. Because if something's chiral, you can't superimpose the image, because this would be the image in the mirror, and if I put it on top of what's making the image, you can see they don't match. And that's exactly what we did with these particles. Okay? Do you see how it's turning it in space? That's what chirality means. So there's another layer to the whole isomer story. Okay? Because you could have a chiral isomer. Alright? And that's it.